is Mr. Kinduri, a physics teacher. Welcome to our ETETA program in collaboration with Pixel International. Today, we are going to see how to answer correctly questions that appears in National Examination Council of Tanzania. For example, this was question number 10, NEPTA 2020. This question number 10, it consists of 3 parts. We have part A. We have to distinguish the concept of conductor, semiconductor, and insulator in terms of their energy band. Part B, you are given a figure here. We have this figure, and this figure shows an electric circuit. We have to study it careful and then to find the value of X, which is allocated here in our diagram, and to find the value of R, this one. Also, part C, from the figure above, we are required to find effective resistance. Means what? Total resistance. So this was the question given by NEPTA. It was question number 10, 2020. So we are going to see how to answer this question correctly. Let us see our solution. Let us start with the part A. The question wants us to distinguish between conductor, insulator, and semiconductors. First of all, we have to distinguish this according to the energy band theory. So we are going to see what is behind on conductors and what is behind in insulators and semiconductor in terms of energy band theories. In conductors, according to energy band theory, we have valence band and conduction band. Conductors are made up of valence band and conduction band. But this valence band and conduction band normally overlapping each other. By doing so, it influences the electric fields. The charge carriers easily move to the conductor, to the conduction band, and this results into easily flow of current. When you come in insulators, we have valence band and conduction band, but also we have what we call forbidden gap. Simply, it consists of 3 gap bands. We have valence band, conduction band, and forbidden gap. But here, forbidden gap is a gap or a band which is found between valence band and conduction band. But in insulator, this forbidden gap is very large. This being wide or very high, thus there is no flow of what? Electric charges. Simply in insulator, there is no flow of electric charges because of forbidden gap to be very wide. When you come in semiconductors, in semiconductor also, it has 3 bands. It has valence band, conduction band, and forbidden gap. But here, the difference is, in semiconductors, forbidden gap is very small. Or we can say that it is moderate in size if we compare with what? Forbidden gap which is found in insulators. Being so, charge carrier can flow to the what? To the conduction band. So this is how we can distinguish between conductors, insulator, and the semiconductors in terms of energy band theory. Also, you may, it will be good if you include illustration as I tried here to draw here. Okay, as I said that it is better if you can include the diagrams to show the how you can include diagram to distinguish between the conductors, insulators, and the semiconductors. As I have said that in conductors there is no what? There is no forbidden gap. We have conduction band and the valence band. This conduction band and valence band are overlapping to each other. In insulator, I said that we have conduction band, valence band, and the forbidden gap. But the forbidden gap is very wide, as you can see here. In semiconductors also we have conduction band, valence band, and forbidden gap. But forbidden gap is very narrow, very small. So this is how we can distinguish between conductors, insulator, and semiconductors in terms of energy band theory. Okay, now let us go on with the question part B. In part B, we are given this diagram or figure, and we asked it to find the current that is flowing through this resistor and the value of this R. So this was our given figure. We are given this current, which is 5.2, entering into these two resistor R, and another resistor here which is given as 4.0 ohms, and this current is distributed into X and 3.2 ampere. So from this first of all you have to know how they arranged these two resistors, or what type of arrangement in this figure. If you look careful, you may find that R, this resistor which is given as small r, and these 4 ohms, they are in parallel. If they are in parallel, meaning that the total current here, which is 5.2 ampere, is distributed into R resistor and another into 4 resistor. So means what? Here at the junction is, let the current which is flowing to X be I capital I R1, meaning that the current that is flowing here is through R, small r, and the current that is flowing through these 4 ohms is equal to IR2. So the total current which is 5.2 will be equal to the current that is flowing here plus the current that is flowing this resistor. So our total current is equal to total current flowing through R1 plus current flowing through R2. But total current, as I said, the total current here, 5.2, this is our total current. The current that is flowing through X, B, I, R1, and the current that is flowing through 4 ohms resistor is equal to 3.28 ampere, which is given here. So here, we are going to just to substitute these values into our equations, as it is shown here. So our total current is equal to the current that flowing through X plus the current that is flowing through 4 ohms resistor. So our total current is equal to 5.2. Our current that is flowing through, R4 is equal to 3.2, and the current that is flowing through R is equal to what? Is equal to X. So here is just the matter of mathematics. We have to take the 3.2 current and then subtract it from 5.2 ampere. After subtracting, you get that X is equal to 2 ampere. Means that the value of current that is flowing through R, small r resistor, is equal to 2 ampere. Remember, in this part B, question number 10, part B, first of all, we have asked it to find the value of current that is flowing through X, and the other part is to find the value of this R. So the value of X is equal to 2 ampere. Let us now move to part B, which is to find the value of this unknown resistor. In order to find the value of this unknown resistor, first of all, we have to find the potential difference which is flowing through this 4 ampere. If we will be able to get the voltage that is flowing through this resistor, we can use this voltage together with the value of current here, which is 2, to find the value of unknown resistor, which is given by small letter r. So, in order to find the value of r, first of all, let r, which is unknown, which is we required to find, be equal to r1, and the r2 be equal to 4.0. This was given. R1 and R2, they share the same voltage. They share the same voltage because these two resistors are in parallel. Since they are in parallel, so first let us find the voltage across R2, as I said. Then after finding the voltage which is across R2, we can use it together with previous X, which is 2 ampere, to find the unknown resistance R, which is R1 or small letter r. So we know that from Ohm's law, V is equal to Ohm's law equation. V is equal to IR. V is equal to IR. Our task here, first of all, is to find the voltage across the resistor R2. Then we have V. V here is voltage across R2. Will be equal to current I, the current that is flowing through R2, times the value of resistor R2. So it is 3.2 times 4. If you multiply this, you get 12.8 volts. This is voltage across R2. As I said that R1 and R2, they share the same voltage since they are in parallel. We use this voltage, which is passing through resistors 2 in resistor 1, in order to find what? To find the resistor R1 or small letter r, which is given in our questions. So first the voltage through R, which is a non-resistor, will be equal to 12.8. Since R, this small r, will be equal to R1, and R1 and R2, the voltage which are crossing R1 and R2 is the same. So also from Ohm's law, V is equal to IR. Then if you make R as a subject, you may get that R is equal to V divided by I. Here, this is voltage, which is equal to this one. We are going to use that 12.4, and we have current which is flowing through X. We are going to substitute in this equation. So we have 12.8 V divided by I. I is the current that is flowing through a non-resistor, which is equal to 2I. If you divide here, you get 6.4 ohms. So the value of X is equal to 2A, and it is the value of R, which was a non-resistor, will be equal to 6.4 ohms. This is part B. Let us now go to part C. In part C, we were asked to find the effective resistor. Effective resistor means what? Means the total resistor. As I said in part B, our resistors are connected in parallel. So we are going to use the formula which is purposely used for calculating the total resistance when resistors are connected in parallel. And our formula is this. We can use this formula where RT means total resistor. We have R1, R2, the product of resistor divided by the sum of the resistor. We can use this formula to find effective resistor. And remember, R1 was small r1, RR. So its value is equal to 6.4. So we take 6.4 times R2, which is 4, which is given in figure, divide by 6.4 plus this one. If you multiply here and divide, you will get R total is equal to 2.46 ohms. So this will be the effective resistor. So finally, we can say that the effective resistor is equal to 2.46 watt ohms. So this is how you can answer this question as it was given by National Examination Council of Tanzania 2020. Thank you. See you next time.